Okay, let's get started. Hello everybody, thank you for coming to this talk about .NET Core. This talk is going to cover what are the components that build .NET Core and how they connect to one another, how they play, all the moving parts. How many of you are using .NET Core today? Okay, quite a few. How many of you really understand the versioning of every part of the things that operate with .NET Core? Only you. Thanks, Alex. So, in this talk, I'm going to cover exactly those components and a bit about the versioning problems that really hurt right now, and hopefully they will get better. And let's get started with talking about these slides. A few years ago, around 2015, Microsoft has showed this image to the world, declaring its love to Linux. And people who used .NET in the past were a bit skeptic and didn't really understand what's going on behind that. But since then, we saw a lot of movement, we saw a lot of investment from Microsoft in its technologies to support Linux. One of those technologies is what we know today as .NET Core. And basically, .NET Core came to provide us, the .NET developers that were using .NET for years, feel like we're appreciated again. Like we can take the skills we already had, we already learned, all the lessons that we learned from the past, and use them for writing applications that can be run on any platform, such as Linux. So, who am I? My name is Tamir Dresher. I'm a consultant and an architect from Israel. Till recently, I led the cloud division in a company called Code Value. I'm also teaching in the Rupin Academic Center, Software Engineering, and I am the author of the book .NET Core, RX.NET in Action. And I have another talk tomorrow about reactive extension, RX.NET, so I would really be happy to see you there as well. I'm a Microsoft MVP, and my Twitter handle is written above, and you can go and follow me and ask me questions if you like on Twitter as well. So let's start with talking about what exactly is .NET Core. So the first thing we need to understand is that .NET Core is a new implementation of .NET. Some of the things that was written before has been adopted and being taken to used inside .NET Core, but a lot of things have been re-implemented, a lot of new things have appeared, and now we have an implementation of .NET that is much more modular. A lot of the pieces that we know inside the framework class library has been separated into their own kind of package and libraries. It is much, much more performant, and there are a lot of benchmarks that you can go and see about how performant it is comparing to the full .NET framework. And it's now separated. All of the pieces inside it's separated, so it's much more agile. We see that the pace in which those components are being developed, new versions came out, it's much more faster than what we knew from the past. .NET Core is cross-platform and cross-devices, which means that you can run a .NET Core application on all kind of versatile platforms, Linux, Mac, of course Windows, and all kind of distribution of Linux. And you can use it to run it on different devices, IoT devices, mobile devices, and so on. .NET Core also provides us a capability of side-by-side execution, which means that unlike in the past, where we install .NET Framework on the machine, all the other applications that we have on this machine share the same .NET Framework. And if you had a new version of .NET Framework that might have introduced a bug, the application that worked perfectly fine before could have been affected. But now with .NET Core, we can run different applications, each with its own version of .NET Core, with its own version of the framework of the runtime, without affecting one another. Being a separated implementation of .NET, we have what we call the pay-for-play model, which means that if I'm using only a small part of the framework in my application, I don't need to get the entire framework with my application. I don't need to deploy my application with all the framework components, with all the framework library. If I'm only using, let's say, the system.io namespace, I can just bring the system.io package, which makes my application much thinner and much smaller to deploy. And of course, .NET Core is an open source implementation. You can go into GitHub, you can go and check the code, you can submit pull requests, you can enter new issues if you find something, and everything is in the open, and you can go and just delve in by yourself. So to understand what's going on with .NET Core and how everything is connected, we need to understand how the traditional full .NET development process was happening. So usually you have your CS files, all kind of files that include your code in C#, for example, and in your code you reference other kind of libraries. For example, I'm using the .NET framework, so I have an implicit reference to MS Core lib, where all the implementation, or most of the implementation of the framework class library sits. I run the compiler, CSC, it's the C# compiler, and I get an assembly, which can be a DLL file or an executable file, and inside we have the IL. Right, this is the intermediate language that describe my code as an independent, machine-independent language. Later, when we take this binary, when we take this executable and execute it, we get a new process inside the system. And this process, because it's a .NET process, it has kind of a bootstrapper, and this bootstrapper goes and load the MS Core E, which is a file you get when you install .NET Framework on your machine, and the role of this file, of this DLL, is going and finding the best suitable CLR to your process. So it finds it usually in the Windows directory under the Microsoft.NET and the version of the framework that you use. It takes the CLR DLL, which includes all the CLR components, and load it into your process. And in this point, you have the CLR running inside your process and starting to execute your code. To take this IL code and turn it into a machine-dependent code with instruction that your machine can run, you have the JIT, the just-in-time compiler that takes the IL and transforms it into the machine-specific code. And we got all kinds of components that are running there, like you have the loader, which is called the fusion, which knows, and because it finds that we are trying to use a type, let's say console, and we try to run something from it, it will go and load the DLL, the assembly that contains this type. And this fusion will go and now will find the MS Core lib that is installed in my machine, load it as well, and now it will start to execute it. And if more assemblies, if more types are needed, it will go and load them from the correct places. And we have all kinds of components. We have the garbage collection and so on and so forth. So this was the traditional way of running .NET, full .NET application. In .NET Core, things are similar but a bit different. And we need to understand a few of the concepts that build this entire .NET Core ecosystem. Now, one of the problems we have today is that all those pieces have different versions. And when you try to reason about what are the things you need in order to run .NET Core, you basically get lost. So the first thing we have is the .NET Core Runtime. And when we say runtime, runtime is what go and runs the application, the .NET Core application that we are trying to execute. And it basically contains the core CLR. And together with it, we also have a bundle of the core effects. The core effects is the framework class library, which include all the things that we need to use, that we want to use from the .NET framework. And this usually goes and installed inside, if you're on a Windows machine, in your program files under the .NET folder. And inside you have a shared folder which include the different versions of the runtime. You can have multiple runtimes installed on the same machine, and you can run multiple versions of the runtime for different kind of apps. This is what you usually go and install on machines that only need to run and execute .NET Core applications. As developers, we need more things. We need more tools in order to build our application. And for that purpose, we have the .NET Core SDK. And the SDK includes the runtime that we talked about before, but also we get other tooling and templates that will allow us to create new application. And it also has a cache of packages that we normally use when we create a .NET Core application. And this sits as well under the .NET folder, but under the SDK, the subfolder of the SDK. Between those two, we have another component, which is the .NET Core Cli. This is a command line tool that we use in order to either build or execute our .NET applications. And inside this .NET Core Cli, we have the most significant piece is the .NET command, which, given different flags, will allow us to do different kind of actions. And you can go and download the pieces that you need and put it on whatever machine and whatever platform you need in order to execute it. And as I said, one of the things that make people really hard to understand in this sense is every piece here has different versions. So you can have today a .NET Core runtime of 2.0 or 2.1. You can have a .NET Core SDK of 2.1.200, and you can have a .NET Core CLI of 2.1.400. So you have different versions, but they all try to play together and get us the agility so they can go and evolve independently. Today should be released the new version of .NET Core, the 2.1, and then the entire versioning system will be merged into one version. They will have a different feature version or build version, but the major and minor will be the same, so we hopefully will not have this difficulty of understanding what goes together. So now, let's take the same example, and we have the same CS file, but now instead of going and referencing the MS Core lib, we're actually going to reference a package, which is the Microsoft .NET Core app. This package is a meta package, which only includes the other dependencies that we need to run our application. And basically, when you install the SDK on your device, you also get the cache of all those inner packages that it includes. And you can think of it as being the new MS Core lib, only that now, instead of having one assembly, one DLL that includes all the implementation, it is separated into different pieces, different packages for every module that you have. Instead of running the compiler, we go and we run the .NET command, which we also call the driver. .NET is the driver, and giving it the flag of build, specifying we want to take this project or this file and build it. And again, we will get the same IL as we knew before. In that sense, nothing has changed. And we get a DLL. Everything now is a DLL, unlike in the full .NET framework when you could compile and build into an executable or a DLL, a library. Now, everything that you compile is a library. But you can't really go and execute a library. So what do you do? And we'll talk about it in 1 minute. Together with this assembly that was generated to us, we also get a bunch of files. We get these runtime config files, runtime config.json and runtime config.dev.json. And we get a dependencies.json. And I'm going to show you what those files include and why we need them. So now that we have this assembly and we have these JSON files, and we wish to execute this code, we will run a command of .NET and giving the name of the assembly that contains our application. So the .NET driver now knows it needs to go and execute this application, and the .NET is now going to be the host of this application. And what this gives us is for different machines, for different platforms, because we have different installations that are based for this specific platform, the .NET host will be adopted and adapted to this specific machine. So now the host will take the same assembly that we can distribute it to other kind of frameworks and other type of platforms, and it will know to load it and start to execute it. So we get the same process as before, only that now the process is actually the .NET process. And if you look into the task manager or the other process managers that you have, you will see that we have a lot of .NET processes that are running there. And each one of those processes execute a different DLL. And now, this process, the .NET host, needs to understand really what is the runtime that it needs to go and start executing. Because we might have multiple runtimes on the same machine, and we can have multiple DLLs, multiple assemblies that were built for different kind of runtimes. So in the installation directory of the .NET Core, we will find the correct runtime based on the version that was embedded in the files of the JSON and the depths. So the .NET Core runtime reads those files and finds out what is the version that we need. Based on that, the core CLR, the correct core CLR, is being loaded and started to execute in my process. And the same mechanism that we knew before of having a JIT compiler and having a loader and having the GC is the same. From that point, everything behaves the same. Only that now, instead of using mscorelib, that was referenced by my code before, now because I referenced the package of the .NET Core app, the system understands that it needs to load the correct assemblies for the different modules that I used. And those modules are the ones that are part of the core effects. The correct core effects is for the specific version of the runtime that I'm using. So let's see it in action. So I already installed .NET Core on my machine, and to show you that it's there, I'm going to run the .NET command. And now you can see that it's here. If we go and look at .NET --info, we'll see a whole bunch of information, interesting information. You can see that I'm using right now a command line tool of 2.1.300, and this is a preview version. You can see at the bottom that I'm also having a .NET Core shared framework host, right? Which is, in this case, the same or very similar version. This is 2.1.0, unlike the 2.1.300. Okay. Also, if I want to get into a deeper understanding, I can also specify that I want to list all the SDKs that I currently have installed in my machine. And you can see that I have a lot of SDKs for all kinds of versions that were released during the years I installed it. So I have multiple SDKs, and basically I can go and compile and build different .NET Core application for different runtimes. I can also go and list the runtimes that are installed on my machine. You can see I have different installation with different versions. In most of the cases, you will use the latest SDK version to the latest runtime version, and it will go hand in hand together. If I go into a Linux that is running on my machine, this is Ubuntu, and I run .NET here, I have another installation of .NET for Linux. And if I see the info here, you can see that right now, this is a different version of the .NET tool that is installed for my Linux. So let's create a new application in Linux, try to run it, and then we will run it in the Windows machine, which has different version of the SDK. So to create a new application, let's create a new directory, call it a new app. And let's write .NET new console. The .NET tool that we have also gives us a lot of utilities that we can use. One of those utilities is the templating utility. You can install and use multiple type of utilities of templates, like the one you had in the full Visual Studio. So basically, now that I wrote .NET new console, it's me asking that .NET tool to create me a new console application. Because I'm doing it inside a folder called new app, automatically the tool will take the name of the folder and use it as the name of the project. And you can see that it's now generated a few files for me. It's generated the new app csproj and the new app and the program inside. I have the program CS, and this program CS is just a simple hello world application. Okay? So now I want to build this application. To do that, I'm writing .NET build. Because I'm inside this project folder, automatically it will build this specific project. And I'll get at the end an assembly, a DLL file for that application, the new app application that I created. And I can go and run this application by now saying that I want to do .NET and specifying the name of this assembly. And I get the response back, and it worked. Now, going back into my command line, the Windows command line, and let's go into this new app folder. And now, again, I'm going to specify .NET and giving the name of the assembly, the same assembly that I just created inside, and it will work in the same way. Newer version of the SDK, newer version of the runtime will always run older versions. But if I will do it the other way around, if I have created my new project inside this command line that is using a new version, and it's using .NET Core 2.1, I wouldn't be able to run it in the Linux that I have because it has an older version. So how does the framework, how does this tool know to use specifically this runtime, or which runtime is being selected? So let's look inside what was generated in the bin folder. This is the files that I got when I built my project. And you can see that I have this new app DLL. This is the one containing my code, the one that I ran. I have a PDB file for debugging, and I have those deps and runtime config files. Runtime config and runtime config.dev are basically the same. The only difference is that dev is an optional file, which we usually use for development. If we look inside the runtime config file, you can see that it specifies inside that I'm using the framework version Netcore App 2.0, okay? TFM is short for Target Framework, okay, moniker. So this moniker, this little string, specifies that I want to use .NET Core 2.0. And inside my framework, I'm specifying, again, which framework I want specifically to use. Because the framework is a NuGet package, and those files inside might be built for the same list of APIs that this framework is using, but it might have bugs. So it's possible for Microsoft and the community to release new version of this NuGet package, although it's the same APIs of the framework, only with new corrections and new bug fixes. So eventually, I might have 2.0.1, which still means that I'm using .NET Core application 2.0, only that this is a new and fixed version of the framework, of the same 2.0 framework. So this is the runtime config, and now when I run the application and the .NET driver reads this file, it understands what runtime I want to include. And I can go inside this file and specify the specific version of the runtime that I want to use. In the dev.json, we have additional things. And to understand what those things are and what is this depth.json really is, let's go and see another example. So I have here another Hello World application, the same one, only that now I went and installed the Newtonsoft JSON package. Okay, and if you are not familiar, this is the new CSproj format. With .NET Core, we also got a new format for CSproj, which is much thinner, it's much stronger. And now I have all my NuGet dependencies inside the CSproj and not in the packages config file as before. And this a new format, you can use it also for full .NET framework applications, but it started with the .NET Core. So in here, it's written that I'm using newtonsoft.json. So if I'll build this application and I'll go into my output folder for this application, and we'll take a look inside. So I got the same files as before, but now which might be a little surprising, I won't see the Newtonsoft JSON DLL. It's not included. And it's not because I'm not using it, because if I'm doing the same with the full .NET, you would see this file included. But it's not been deployed into my output folder. So we all know that if I try to run an application and the assembly is not there, and I haven't registered in the GAC or something like that, my application will crash because it wouldn't find my assembly. But I can promise you that even if I would be using this Newtonsoft JSON inside my code and run it, everything will work perfectly fine. And why is that? If we go and look into this depths JSON file that we have here, you will see that now this deb file, let me just make it a bit smaller, is saying that my application has a dependency. This depths file is the dependency manifest. And inside this manifest, all the dependencies that I have is written inside. And basically saying that my code needs to use the Newtonsoft JSON, and specifically the Newtonsoft JSON DLL for Net Standard 2.0. And we will talk about what is Net Standard in a bit. And inside this file later, we also get other types that really specify what is the package. Okay, so now the runtime knows that I need to use this specific package. And if I'm trying to get to a code that now needs to load this Newtonsoft JSON DLL, it will know it needs to search for the package. But still, how does the framework know where is the package installed? And now we can go back into the dev JSON that we have here. Because I run it in a development machine, this deb.json file include the additional probing paths. Probing paths are those paths where I'm telling the runtime to search for packages and assemblies when needed. And you can see that one of those things that we have here is my user directory and .Nuget. And if I'll go into this folder and into this packages folder inside, I will see all the packages that I've been using inside my developer machines. It's kind of the cache for NuGet. Unlike before in the full .NET framework, when we had all the packages in the solution folder, and so if I have multiple solutions on my machine, all using Newtonsoft.json, I will have multiple copies of the same package. So with the new version that we have with NuGet, we have a packages cache. So instead of installing the same package over and over on multiple places, we have a single place, which is configurable. And now, when my application is running and searching for that file, because in the depths file, it is specifying I want to use this package, and in the probing path, I'm telling that the packages are inside my cache, it will go and search it over there. So a good question will be, do I always need to do this kind of caching? What if I want to deploy my application as a whole? I don't really want to go and spread those files over in different places. So it's pretty simple. Until now, all I did was just building this app. If I want to go and deploy this application with all these files together, all I need to do is specify .NET publish, which means that I want to publish my app as a full, with all the dependencies that it has. And if we go and look now, this went and created a new folder, which is the Net Core App 2.0 publish. And inside, it will have all those files. Another way to do it, if you're using the full Visual Studio, we can go and just right-click on the project and select the publish option. And with that, we can go and specify where is the folder we want to publish to. And again, all the things, all the dependencies, Newtonsoft and others, will be deployed into this folder. And now I can just go and run it without needing to have any NuGet. Okay. So let's go back to the slides. So we saw those build artifacts that we have, and we kind of understand what they have. Beside of the runtime config being there to really specify what runtime I want to use, the runtime config also allows us to create and configure new configuration for my application. One of the things that you might have noticed that is missing from my .NET Core app, which we all know from the full .NET, is the app config. We no longer have this app.config file or web.config file. So the runtime config file is kind of the new app or web config file. In the app config file, you had app settings that you might have added for your application, but you also add all kind of configuration to really control the runtime that is running. For example, one of the things we usually did inside app config is deciding or controlling what kind of garbage collection we want in our application. We can specify a server garbage collection or a workstation if we want it concurrent and other kind of things. So where do we do it now? Basically, most of the things that you used to put inside the app config, you can put it inside the CS proj. And you can see here, for example, that I included a server garbage collection, a new tag, and I specified I want it to be true. When I now build this application, this configuration that I written in my CS proj is actually being output into the runtime config.json. So you can see here I have config properties, and inside system.gc.server is true. So even if I wouldn't go and specify it in the CS proj and just included it in my runtime file, it will work the very same way. And now when the .NET runtime is executed, it reads this runtime config, and for every config properties that it's seeing inside, it will go and do the necessary configuration. And you can go into GitHub, and there's a full list of all those configuration properties that you can use to really control the core CLR. Many of them are not documented, but I guess that over time we will see more and more. But if you need something that once you put inside the app config and you don't know where to put it now, this is the place to go and put it inside the runtime config.json file. Another thing that people tend to ask is, how can I specify the specific version of the runtime I want to use? For example, a year ago, I created a new AWS Lambda function with .NET Core, and everything worked fine. And then I installed a new SDK on my machine, and suddenly I got a response from AWS that my Lambda can no longer be executed. And I was like, what the hell? It all worked fine a minute ago. Because all the things inside the SDK are based on the NuGet packages. A new NuGet package was used, and this NuGet package included a new version of the core effects, which was not supported at that time by AWS. So what do I need to do if I have all kind of projects now that I need to go and change? And I haven't really changed the code, I only installed the new SDK. So here's a tip. If you include a file, global.json, in your folder, for example, if you put it in the specific project folder, the .NET SDK, the .NET build machine, will understand that you want to use for that specific project the specific SDK that is written here. But if you put it in higher levels, it will affect all the levels underneath. And if you really want to see how it is being done, and this is another tip, if you want to understand what's going on inside .NET Core, if you'll turn on the flag core host _trace, just an environment variable, and put it 1, it will print to the screen all the steps that the .NET Core tool, the .NET Core SDK, the runtime, everything that is doing inside. So I turned on this flag, and you will see that when the application is started to execute, this .NET Core runtime will go, the .NET Core SDK will go and start to search inside my folder structure. It will start from the specific project and then go up all the way until it will reach the root folder, the root drive of where your project is located, and then it will stop. And it's searching for this global JSON. So if you want for some reason that all the projects that you have inside your drive to use the same SDK, all you need to do is just put this global JSON with the SDK version, and it will affect all those projects inside your drive. Okay, so up until now, I only showed you one way of deploying a .NET Core application. This was the framework dependent deployment. Basically, I just got an assembly, a DLL, that I can go and distribute. Even if I do a publish, I will only get those assemblies that are the dependencies of my application, and I can distribute it as a whole and give it to whatever place, whatever platform that want to use my application. This means that those places that I want to use my application need to install the .NET Core Runtime. This is why this is a framework-dependent deployment, because if I'm taking these files and try to execute them on a machine that doesn't have this specific runtime that I need, it will fail to execute. But it will give me the possibility really to get a thin deployment and distribute it to whatever platform that I want. The second deployment option that you have is the self-contained deployment, which means that I want to embed the .NET Core runtime together with my application. And so instead of going and installing this runtime on multiple platforms or multiple places, all I need to do is just embed this runtime, take this deployment unit, and pass it along where it will be run. The downside of that is that I need to specify the platform to which I want to build my application to. This is why it's the self-contained, because it contains the specific runtime for the specific platform that we want to use. Basically, the only thing that is happening here is that from my dev machine, the .NET Core runtime that I want to use is being copied into my output folder. The name of the .NET tool is being renamed to the name of my application, and it's specified inside that when I run this .NET tool, it needs to run the assembly that is located in the same place with the same name. That's all that is being really done. But together with this file, I also get the platform-specific things. To do that, I can go into my CSproj file and specify inside the runtime identifier to which I want my application to be available to. For example, in this case, I specified that I want it to be available for Windows 10, a 64 distribution, and to OS X 10.11. Okay? Then I need to go and publish as we've seen before, but specify to which runtime I want to publish to. So I do it first for Windows 10 and then to OS X. This is one way you can do it with the command line. Another way to do it is if you have the full Visual Studio, and this is a project like the one I just showed you. It has here those dependencies, those runtimes that I'm targeting to. And now if I right-click and click on Publish, I can specify in my Publish profile to what specific target runtime I want to target. So let's select this OS 10 and do a Publish. So it will go, it will publish, it will now download, if they are not inside my machine, the NuGet packages that include the necessary file for that specific target. And if I'll go now into this output folder and look inside, you'll see that I have many files inside. All kinds of files. Some of them are native files that I need. And this file that you see over here, self-contained deployment, which is the name of my project, this is the executable that when I take it and put it inside macOS and run it, it will start executing my application. And you have all kinds of other things that you might need to run this application, like the ones you see here. Many native libraries that are needed. So if you need to target to multiple platforms and you don't really want those platforms, those target machines to install the runtime, you'll just add those runtime identifiers to your CSproj, publish to each one of them, and just deploy and publish the output of each one. Behind the scenes, you'll see, if you're using the the command line tool that the moment I tried to build this for those different platforms, it started to download the different targets NuGet packages. So I got this .NET app host, for example, for OS X. Why? Because I need the host that is specifically built for that specific host. So you should know that when you target multiple platforms, you will have a lot of NuGet packages being downloaded into your machine. Okay, the next thing I want to talk about, which is a must when we start to talk about cross-platform application, is this notion of .NET Standard and how you can create reusable libraries with .NET Standard. So what's the problem? Right now, we have .NET Framework, which you can create application with it for WinForms, WPF, ASP.NET, and so on. You have .NET Core, which you can use to work with UWP and console application and ASP.NET Core and so on. And you also have Xamarin, which I haven't touched, but Xamarin is using a different CLR, which is based on the Mono. And Xamarin also you can use to create application for iOS, OS X, and Android, and so on. For each one of those frameworks, you have different class library. For the .NET Framework, you have the framework class library, the FCL. For .NET Core, you have CoreFX. For Xamarin, you have the Mono class library. Now, each one of those is different. It has different implementation. It might have more APIs or less APIs from the others. For example, it makes sense that in the framework class library, you will have the registry APIs that you can use to read and write into the registry. But in CoreFX, you don't expect to have them because CoreFX can be used in other platforms other than Windows. So if I now want to write a class library and I want to use it in all those places, which of those frameworks do I need to use? It's now becoming a problem, right? So one possible solution that we've seen in the years was the portable class libraries, where you could create a new portable class library. You have this dialog, and you'll select the targets like .NET Framework 4.5, Windows 8, Silverlight 5, and so on. And basically, every intersection between those targets was given a unique identity as a profile. For example, the intersection of the APIs that you can use with .NET 4.5, Silverlight 5, and Windows 8 was called Profile 47. Now, in your dev machine, you will see in the installation of the framework, the .NET Framework, you will see a folder for each one of those profiles. In each one of those folders, you have all kinds of files, for example, MS-Core-lib, which when you open, for example, with some disassembler, you will see that it's only contain type forwarding attributes that specify that if I'm running this now in my platform, and I'm trying to use, for example, the iComparable interface, it needs to be redirected to the assembly that contains this file. And this type forwarding attribute specify to which specific type I need to forward to. So basically, I have this MS-Core-lib without any implementation. The problem with this behavior and this technology was that if I have new frameworks, new version coming out, I need to specify all kinds of new profiles, and it was not scalable to use. If I have a class library that I already targeted to specific platform, and there's a new platform coming out, what do I do now? I need to recompile my code. So a better solution is, instead of going and find the common denominator between those things, why not declare what is the API surface that must be implemented by the different places? And this is the role of .NET Standard. .NET Standard will expose the API surface that every framework must implement in order to be .NET Standard compatible. And it works in an additive way. So if I have .NET Standard 2.0, it will include all the APIs in .NET Standard 1.6 and more. So if I now target my class library to .NET Standard 1.6, everything that talks with .NET Standard 1.6 and use the frameworks that include it can use it, including those that are targeting .NET Standard 2.0. The way it works is really, really similar to what we've seen. I'm creating a class library, and inside my CS project, I'm specifying that I want to use Net Standard. And implicitly, you will see over here that I have a NuGet package that was included in my project. In this case, and this is again where the versioning is confusing, this is .NET Standard 2.0.1. Why? Because it's a new version of the package, but not a new standard. And for every version of the standard, I have different packages that includes those standards. And if I'll go into this NuGet package and open the specific version, I will see inside an assembly called Net Standard DLL, which contains only empty implementations for the different types. So for example, array list that is part of system collection namespace is empty. You'd see an empty implementation. And this is what sits in my NuGet package. When I go to the runtime where I installed my .NET Runtime and installed my application, you will see another Net Standard DLL, only that now this Net Standard DLL redirects with the type forwarding to the correct implementation. And array list, for example, which is usually in the system collection, is actually for .NET Core in another assembly, which is a new one, system collection specialized. And if we go to this DLL, we see that the real implementation is there. In this case, in this way, you can have different distribution, different frameworks, different implementation, all using the same Net Standard and just redirecting when you need to use specific types to the specific DLL that contains them. Okay, so let's recap. In this session, I tried to explain what is .NET Core, why it's so powerful, and why you should use it to create cross-platform .NET application. I tried to explain all the different parts that we have inside, all the SDK, runtime, the different artifacts that you get when you build a .NET Core application. I talked about the different deployment model, the self-contained and the framework dependent. And lastly, I discussed how you can share code with .NET Standard and how it works behind the scenes. So with that, I'd like to thank you for listening. And do we have time for questions? Yes, and we have time for questions. So if you have any, feel free. And if not, I see a question there.
Okay. Can I build my a simple hello world application with .NET Core 1.0 and run it using .NET Framework 4.5, for example?
Okay. So the question was, can I build my application with .NET Core but run it with the full .NET? So no. When we compile an application for a specific framework, it is used by specific framework. So the full .NET cannot run .NET Core application. If you want to share code between the .NET framework, create your Hello World application so that you can use the same code in .NET framework or with .NET Core, you need to put it inside a shareable assembly, which for that purpose you will use .NET Standard. .NET Standard 2.0 can be ran and included in both .NET Core 2.0 and in .NET Framework 4.6.1 and above. Okay? So this is the way you share code. Okay. So thank you very much. And if you have more questions, you can contact me with Twitter, or I'll be outside for the next hour or so. And if you are here tomorrow, make sure to come to my other talk about reactive extension. Thank you.